So today there's two main things that we're going to do. One's called the law of cosines, and one's called Heron's formula for finding the area of a triangle. And as you look at all of these things, I told you before that when we did the law of sines in the video, that you needed to have two angles. Remember that? Angle, side angle, or angle, angle, side in order to use that. In order to do the law of cosines, you need two sides at least. So you'll notice up above here that each of these things that they talk about has at least two sides involved to use this law of cosines. If it has two angles, it's law of sines, two sides, law of cosines. Very important to know for the test. But you'll notice that there are 6 formulas. But what I want to show you is you really only have to memorize one because it's all relative and there are patterns. And remember, math is the study of patterns. So the only one I know is this one. And the reason I know this one is because to me, the beginning part looks like the Pythagorean theorem. C squared equals a squared plus b squared. That's how I remember it. And then what you'll notice is in every single case, when you look at what's going on, there are 3 squared things. One's on the left, 2 are on the right. And there's always a plus between the squareds on the right. And then if you look at the 2 letters that are on the right-hand side, those are the same 2 letters that always come after the -2. And if you look at the angle, it's always the angle that was across from the side that was by itself on the left. So there's always patterns. But what about these 3 other formulas over here? So that's kind of confusing. So what I want to show you is, when I know one formula, it doesn't matter. I can always change it into anything else. So this formula right here, at the bottom left. If I move the a squared and the b squared to the left-hand side of the equation, I would have c squared minus a squared minus b squared equals negative 2ab cosine capital C. You don't have to actually write this down. I just want to show you how I can get to any formula. Then, I don't want that negative 2ab. Please stop bouncing that pen. I don't want that negative 2ab over there, so I divide everything by negative 2ab. And you notice that these negative 2's, a's, and b's are gone, and I get the cosine of c, which I see in the bottom right-hand equation. But the only difference is, when you look at that bottom right-hand equation, what you'll notice is that the 2ab on the bottom is positive, but in the brown, mine's negative. If I were to multiply that whole side on the left by negative 1 on the top and negative 1 on the bottom, so negative 1 over negative 1, all the signs would flip-flop, and I would see that gray formula. So negative c squared times negative 1, negative c squared. There it is. Negative a squared times negative 1, positive a squared. Negative b squared times negative 1, positive b squared. Negative 2ab on the bottom times negative 1, positive 2ab. Same formula. So whenever I see these 6 formulas, I always think to myself, I know some people memorize all those. I'm telling you, if you know how to manipulate an equation, you only need to memorize one. And I do the Pythagorean theorem looking one. And that's all I know. Okay, just for your information. Down below here, they talk about some kind of development of some formula, blah, 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 whatever. Let's move on. I'm going to get to the law of cosines in a little bit, but I want to jump to the Heron's formula. So skip ahead to this formula. And the reason I want to skip ahead to this formula is I think for us this will be a really quick part of the lesson. And what I want you to see is this formula works when you have 3 sides given in a triangle. Okay, so that's kind of important. It's called Heron's formula, and you're looking for area. You need 3 sides. When they give you 3 sides, here's what happens. You need to have something called the S. The S stands for semi-perimeter, which basically means half of the perimeter. So, for example, in number 4, they want us to talk about this triangle. So I draw a picture. You don't have to draw a picture, but I draw a picture. And it has the sides 13, 15, and 18. In order to use the formula, the first thing that you're going to do is you're going to find this thing called the semi-perimeter. That means, to find this semi-perimeter, you add the 13 plus the 15 plus the 18 and chop it in half. And that's going to be your semi-perimeter, or in other words, halfway around. So if you add them all up, you got 28 plus 18, 46, chop that in half, and you get 23. This is your S, the semi-perimeter. And then after that, all you do is you use the formula. So here's the formula. And into that formula, you just plug in all of your information. So as I plug in my information, this is what happens. To find the area of the triangle that's in purple to the left, I will have the square root of, and then I will have the semi-perimeter, which was 23, times, and then in the formula it says the semi-perimeter minus the first side. So I take that semi-perimeter, 23, take away the first side, which was 13, times the semi-perimeter, which was 23, minus the second side, which was 15, times the semi-perimeter, which was 23, minus the last side, which was 18. You just type that in your calculator, and when you get done typing that in your calculator, try it right now, just to make sure you can get it. I get 95.92. And that's my answer. I'm done. Give that a shot. In number 5, you draw your picture, or not. Put the sides on. Notice how there are labels here. Don't forget your label in the end. The semi-perimeter is where I add up all these sides. So the 42.5, the 37, and the 28.5. Chop it in half. Unfortunately, you get a decimal. Not.
No.
And then, from the formula, to find the area of this triangle, you type in the semi-perimeter, 54, you can do this all in your calculator, and then 54 minus 42.5, and then 54 minus 37, and then 54 minus 28.5, and then take the square root of all that stuff, and I get 518.85 meters squared. Don't forget your label. That'd probably be worth 1 point on an exam. Yes. So if you flip back, I think 1 page now, to number 3, added bonus for today. We're not doing that one. Yeah, thank you. I like mocha. It's on recorded. It's recorded, so if your parents are listening and I don't get a mocha next conferences, you're probably flunking.
Mocha latte or no?
Are you calling me a name?
No, I'm asking what kind of mocha.
A big one.
Big one?
Yeah, big. Doesn't matter. If it has the word mocha in it, it's going to be good.
Alright. Okay.
Turtle mocha.
Okay, so we're back to this law of cosines, and I told you that the only formula that I know is this one. C squared equals A squared plus B squared, because it looks like the Pythagorean theorem. And then the pattern for all of these formulas is a -2, and then whichever letters you see on the right-hand side are the next 2 letters, A, B, and then it's always the cosine, that's why they call it the law of cosines. And then there's an angle, and the angle is the one that was always farthest away, which is capital A, because that's the angle across from
C.
Oh my goodness, see?
C.
You guys knew already. Whoa. And then it was like, whoa. And then I said, whoa.
Nemo.
Yes, good job, Tristan. Alright, so in this particular problem, it says solve the triangles. When you see the word solve, that means find all of the pieces. So they give me 1, 2, 3 pieces. How many pieces are left in the triangle? 3 more. So I have to find 2 angles and 1 side. That's what I'm going to do. So I draw this triangle. Here's the triangle. I'll put capital A over here, I guess. I don't really know. I don't even know what I did on my last time I taught this. There's A, B, C. Little a is 11. That means it's the side across from capital A. Little b is 5. That means it's the side across from capital B. And angle C is 20 degrees. Thank you. Was going to get there. They gave me angle C. Whichever angle they give you, that's the formula you want to use. So actually the one I memorized is actually the one I want to use. If they gave me angle A, I would have used the A squared equals. If they would have gave me little b, or sorry, capital B, angle, I would have used the B squared equals. So whichever angle they give you, that's the formula you use. And if I know one, I know them all. Also, when you do this, it's very important that when you set this thing up that you know that if you're finding stuff after you find the other side, because that's what I'm going to be able to find right now, you always find the largest remaining angle first. Write that down. Find the largest remaining angle first. It's also on the video. I'm going to set up my formula just the way I see it. Oh, do I know little c? No, I do not. So I write down c squared. And then that's equal to little a, which is 11 squared, plus little b, which is 5 squared, minus 2 times the a times the b times the cosine of angle A. Make sure you're in degrees. When you type in this whole slew of stuff in degrees into your calculator, you will see that your c squared is equal to 42.63. Am I looking for c squared? No, I'm looking for c. So I have to take the square root of 42.63, and I get 6.53. That's side C, 6.53. Oh boy. With me so far? So I found, based on the formula they gave me angle C, so I used the C formula one. Next, I'm going to look for the biggest remaining angle. Which angle is that?
A.
A. How'd you know it was A, Tristan?
Because 11's the biggest side.
11's the biggest side. The biggest angle always is across from the biggest side. You learned that in geometry. So I'm looking for angle A next. That means I need to use the A formula. The A formula is